So I'm planning to start this book. So Taming the Infinite, the story of mathematics from the first numbers to chaos theory by Ian Stewart, author of Professor Stewart's Cabinet of Mathematical Curiosities, which I actually have read half of this book. I didn't finish it. Anyway, so this book, see what it says on the back. So, who invented zero? How can imaginary numbers stop skyscrapers from falling over? That's a very interesting question. Where do parallel lines meet? Nowhere, or maybe. And when did you use abstract algebra today? And I like that he puts the answer, yes, you did. Interesting. So, beginning with the first Babylonian number symbols and concluding with Fermat's last theorem and chaos theory, world-famous mathematician Ian Stewart answers these and other fundamental questions in an enlightening and highly readable history of maths, its big concepts, brilliant minds, and undeniable impact on the way we live. Interesting bit on the back. So it says it's an engaging history of maths, guaranteed to illuminate even the most number shy. Okay, we're gonna see. Good. Now the book is not so colorful as the other one. It's quite old, so it was first published in 2008, if you consider that old. I don't know. So those are the contents. I'm really curious to see the shape of logic. Actually, patterns in nature, that should be quite good. Patterns in numbers, chaos and complexity. So I have a couple of bits that I'm interested. Again, it has further reading, which I always enjoy in a maths book because it helps with a lot of things if you didn't understand, or if you're passionate about any of these ones. And always index bit. So I'm gonna go, let's see if I can go through this. It's not as colorful, but it does have some drawings. It's not very colorful, but I'm not complaining. It doesn't have to have colors in. It has some nice drawings, which should be okay. So it looks like a basic, some other interesting, it looks like a basic non-fiction math book with lots of diagrams. So I saw some matrices over there, which is a good thing. Ooh. Some topology, why not? Oh, some other interesting bits, more topology. Interesting. So I like the fact that, again, I always find my favorite mathematician everywhere. Anyway, I like the fact that he also has like bits and bobs about different mathematicians and they're put like that. So it seems like interesting. Okay. No, I saw something about Galat. Interesting. So it looks like an interesting book. I will probably do the same bit as I did with the last one. So I will mark interesting paragraphs, interesting quotes, stuff I didn't know about. So we're gonna see. I really like the title of this page. That should be very interesting. Good, so it looks like quite a lot of information and some interesting facts, just like a short look like this. So I'm quite happy about this and I'm quite excited. So I'm kind of go a little bit faster on the end. Ooh, ancient Egyptians. Interesting. Anyway, okay, so that's what I'm gonna read next. Hope you pick it up as well. So I just started reading this book and I had to just stop on the first page and show you this bit. So, mathematics did not spring into being fully formed. It grew from the cumulative efforts of many people from many cultures who spoke many languages. Mathematical ideas that are still in use today go back more than 4,000 years. And another bit, once a mathematical discovery has been made, it becomes available for anyone to use and thereby acquires a life of its own. Good mathematical ideas seldom go out of fashion, though their implementation can change dramatically. Methods for solving equations discovered in the ancient Babylonians are still in use today. We don't use their notation, but the historical link is undeniable. In fact, most of the mathematics taught in schools is at least 400 years old. So that's quite interesting. And I thought, if more people will just understand this bit, that'll make so much more sense, and hopefully, I don't know, I just have the feeling that they would take maths or see maths differently if they would just understand that everything goes back so much. Anyway, that's the book. Really excited from the first page. So I finished the book. Yay! Finished. Last bit, nothing left to read. So I'm a little bit sick, so sorry for my nose doing this from time to time. So the book is really interesting. I think if I want to vote it, or if I'm going to give it any stars on Goodreads and stuff, I will probably vote, or give it a 5 stars or something. I really liked it. As a history of maths book, it was really, really interesting. So I kind of made some notes. You can see for different type of chapters, he gets very complicated bits. The patterns in natures is more number theory. The system of the world is calculus. Patterns in nature is differential equations, and he gets to some really, really tough things over there. So impossible quantities, that's complex numbers and complex analysis, which I found quite hard to do at uni and stuff like that, so that was quite good. Firm foundations, that's again analysis and the Riemann hypothesis. Impossible triangles, that's non-Euclidean geometry. Algebra comes of age, that's abstract algebra. That was one of my favorite bits, because that's one of my favorite parts of maths I've done at uni. Rubber sheet geometry, that's topology. The 4-dimension, that's multi-dimensional geometry. The shape of logic, that's just logic. How likely is that? Chaos and complexity, that's chaos theory. And fractals. Number crunching, that's number machines, I think. Let's see, 345. Let me see if I remember it right. Yeah, so that's calculators and how they started doing algorithms and stuff, and numerical analysis and computing stuff like that. So he managed to speak about P and NP and stuff like that. So that was really interesting. How likely is that? That's 332. Do you remember? Oh, that's yes, that is probability and statistics, and that was again
really, really interesting. So it's very interesting how the author, at the beginning of each chapter, gets to like some like very basic aspects, and by the end of the chapter, he manages to talk about something very complex and interesting. I wouldn't say everyone will feel comfortable with the maths inside it. I mean, he doesn't have lots of like equations and stuff like that. But at one point, he will just speak about the theorem, he will speak about a concept, and maybe for some people it will be a little hard to understand. But I think still, I found it really interesting. So even though it took me a while to read it, I really enjoyed it. Really, really enjoyed it. So I have a couple of notes I wanted to see. So I have my yellow notes are on why I should say about the book. Oh, there's something I need to say that I did not like about the book. So I just remembered right now. So like, for example, take a look at this one. So every chapter is split into like subsections. Like for example, this one in the logic of shape, the chapter, it has problems for the Greeks. So he starts talking about this one. He starts really nicely. And then he has the book has an extra bit about a mathematician, which is like in this kind of like rectangle. But then the sub-chapter is not finished, and you get to go on to the next one. And you see this one. The sentence is not finished, but he has another one of these like rectangles, like extra information bit. And then he gets to not even this part, but he gets to this part where you need to like finish the chapter and then go back and see what he means with some of these. So I found that bit like a little bit annoying to read because I need to go back and stuff, but after I got the hang of it, it was quite good. So, but it could be annoying at first. I don't know. Kind of depends on your like preference and stuff, and how you like to read the book like this. If you like to go back, if you like to like stop, read what it says in the middle and stuff. I found it more like useful if I just finished the subchapter and just went back to this kind of bits and stuff like that. So also this bit, what geometry does for us, or like anything, it doesn't matter what the chapter is, he will say what that chapter or topic does for us, and he gives like proper examples of where and when we use that bit of maths. I found it so interesting. It was really, really good. I really enjoyed it. Like it has like different, like every chapter has something like this, and I think it's so good to see like some of the applications and some of the bits like that. So I found it really, really, really interesting. So as a whole, I think this is like one of my favorite books for this year. I really, really enjoyed it. So yeah, I hope you're gonna pick it up. I will write a proper blog post about it, and I will write a proper Goodreads review about it. I will put when they're finished, I will put links and everything somewhere so you can properly read it. But I thought I'm gonna do this kind of like a short couple of minutes review on the book.